Alright, hello everyone, how's it going this fine Monday evening? Today I want to showcase something I've been working on and possibly demonstrate how it was done, but this is a complex effect, so I may only show how to do a little bit of it. So this you may have seen on my shorts, my YouTube shorts this morning. I've been actually wondering whether I should post these as regular YouTube videos or shorts themselves. But this kind of curve rolling up effect kind of looks like a nervous system, which people have been reacting to in various ways, from disgust to intrigue, almost freaky intrigue. But it's a cool effect, which I will show you the full effect that I made. So this is a ton of polygons that just go and roll up. I apologize for the performance. Here I'm using all the curves to go and do that, but you can see that, you can see this being used for a ton of cool effects. But yeah. So, the effect is not done. Like, for at least the meshed version, I want to make it so that all these tons of jagged parts right here don't occur. But I may need to go and remake the entire system from the ground up using custom nodes. Unfortunately, we don't have loops, so it'll be a bit more difficult. But I'll have to figure that out off stream and all that. But I want to... Did you set the playback to 30? I did not. Thank you for letting me know. With this one, I'll be mostly demonstrating making this effect rather than playing it back, so this won't be too bad. But the meshed version is too complicated, as you can see here. The part I want to show off is just the curve rolling, which this one can play back at 30 frames per second, which isn't too bad. So I'll wait until just a few more people are in the stream, and then I will begin. So let's see, I don't plan on saving this, so I'll just strip it down to its base components. And then I will start on that, so... The base components. This is the main part up here, which it'll need some explaining because it is rather complicated. Okay. I should actually open a new file, just in case I accidentally press Control S. So I will do that. So I will just Control C, not Control S, copy objects, and move into a new Blender tab. There we go, and I will get started on it. Even though I should probably keep the working version to reference, because I will certainly need to. So let me move it over to the side, and let's get this started. So here we go. Here we have the working version of the curve rolling effect. And now let's go and start making it on this one. So first of all, what we need to do before we get the curves to roll is to make the actual curves themselves. So fortunately for us, that's actually fairly straightforward in Blender. Maybe not the most straightforward thing in the universe, but we use the shortest edge paths node, like this. Let me turn on grid snapping, and then the edge paths to curves node. So we put that in there, and we connect the next vertex index, but we need a end vertex, which kind of works as a start vertex, but, you know, it's named how it's named, and it's named that way for a reason. But in this case, I will assign a vertex in the back right there, and let's get that assigned vertex, that group in here, and now we can see that, boom, we already have edges going to every single part on this mesh. So now let's go and trim these curves just to see if it's working correctly. So as we can see here, it is working, but it looks like we'll need to reverse the curves because they trace from every single point on the mesh to that end point, which was where we assigned it. So there we go, we have all the curves doing that. Which, you may want that. In one of the versions I had in this version, I did a random triangulation, which is just these nodes. But for this one, I'll just throw in a triangulate node, just a regular modifier up here. It gives a more regular result, which actually, that looks pretty cool. But I'll keep it as that for the time being. So here, let me just go and do this. This is our curve setup. So let me go and put that into a nice little frame right there. And also, another thing that you may not want all of these curves right here. Maybe you want to just have about 10% of them. So for here, I'm going to use a random value node for the start points, or start vertices, and we could just reduce it to the amount that we want. I think 20% is good enough, so let me go and put this in here. So this frame is our curves. So yeah, we'll just label them curves. Self-explanatory. And I can actually collapse this because, you know, just to have the necessary information on screen. Now, is there anything else that needs to be done before we get to the fun part, or the painful part, depending on your perspective? Let's see, I'm thinking currently, no, I do not think there's anything else that needs to be done. Oh wait, there is one thing I just remembered. We need to blur the positions by a little bit. This one's optional. We just blur the positions, and then that gives, you know, more of a nervous system effect. Just blurring it by 1 is good enough. So let me go and put that into a frame. That's just for, I'll label it smoothing. Let me put that here. This is just smooth. There we go. Now it's time for the fun part. So let's talk about the concept behind the curve rolling. So what we need to do is rotate each kind of vector, but then, I don't know, depending on its parent, keep the location and all that. In summary, we need to basically, how do I explain this correctly? Take all the vectors of these curves starting at their parent and keep going down, rotate each one, and then make sure that their positions get inherited. So, if I explain that at least partially correctly, we're going to use the accumulate field node to basically stack up each vector of the curve. So for each point, it has like the direction and all of that. So we'll just take the start points and then stack, 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 and it will work. I apologize if I can't explain it correctly. This was a pain to figure out. But, okay, so first thing we need to do is get those vectors, basically the position of the current vertice, and then the next one. So to do that, we need to use a lot of nodes. So first we need the position, and then we need to subtract this from essentially its neighbor's position, so the next one in the line. So if we use an offset point and curve node, and offset it by -1, we should be able to get that. So if I evaluate on domain, evaluate at index, there we go, set this to vector. This should give us the position of the next vertice. So let's go and see what that is. But we may need one other thing, but I'm just going to test this one first. So if we were to accumulate all of those vectors, and then plug this into a set position node, we can see that it actually works. Wow, I am genuinely surprised that worked first try, but it does. So basically, we took all of the curve vectors, stacked them up, and then did that. So another thing that we need to do is set the group ID. So we need the index, then evaluate this on the domain, and this is on the spline domain. Again, I apologize if I'm not explaining this in the best way. Oh my goodness. So I think, believe it or not, this is actually partly working, because we can see that the vectors are kind of stacked up, just not in the correct order, I guess. Okay, so I need to compare to the working version. Okay, so I forgot just one little piece of this. A couple pieces of this. Okay. So over here, let me move this over by a bit. So I need to make it so that if there is no valid offset, basically if it reaches the end it'll revert to the normal index. So we just need a switch node to switch between integers. So if it's valid, it'll go to the offset one, and if it is not valid, it'll go back to the default, in quotes. So if I do that, there we go. That fixes that. That's one thing I learned from some of the pre-built-in hair curve nodes. So there's the evaluate at index, giving us the position of the next point, and then the position of the current point, basically giving us the vectors for all of these curves, the accurate ones. So these right now are reassembled. The problem is they're reassembled at the kind of start position. They don't have their current offsets from their parent's point, if that makes sense. So if I were to assign another start point, it would work, but it would all be, you know, starting from 0, 0. So we need to simply add the start point of the curve. So fortunately, there's a curve root node, which gives us the root position right there. So if we plug that in, we can see that it now works. So if we were to add in some more start points, they are correct, which is very nice. I just need to make sure... Yep, nope, all that seems to be good. So now, finally, we can rotate the vectors. So we can put in a vector rotate node, and then rotate them, but we can see that they are rotating in a very funny fashion. That's because the rotation needs to be accumulated as well. So this basically stacks it. So here it would be like, if it were 0.1, it would be 0.1, 0.2, 0.3, 0.4, 0.5, and so on. So I'll label this reassemble vectors. So curve vectors and then reassemble vectors. This part is the add start offset. There we go. Again, I apologize for not explaining this too well. This is complicated. It took me several days to figure out on and off. Okay, so now, instead of accumulating the vectors, we will accumulate the rotations. So let's plug the leading into here, and now we should be able to see that it is rotating the curves properly. But we need to do just a few more edits until it's correct. So this is the rotation amount. Rotation... Stack rotations? Yeah, stack. Oop. Stack rotation... Apologize for the misspellings. Rotation amount. There we go. We need to set the rotation axis, because right now we can see that it's just plainly rotating on here, which is not great. So we need to make it so that it rotates along the normal of this object, or the mesh. So what we need to do is go back to our start geometry and then store the normal, which fortunately for us is pretty simple. So let's have this be the normal right here, and I will label this normal. There we go. And now we can access this even after the edge paths to curve conversion and all that. So let's get the normal, plug this into here, and we should see that more weird stuff happens, which is a little unfortunate, but let's just do a few little fixes just to make it a little more clear of what's going on. So right now, all the rotations are stacking up. Let's make these rotations controllable before we do that one last bug fix. So let's get the spline parameter, and then we'll just add to this to kind of move where the start of the rotation is, like this, as we can see, and it's working quite well. You may want to use the length, because that gives the more even output. There we go. So the start and end points. And then we will multiply the output so that we could say, oh, how much do you want it to rotate? So finally, it's working quite well. Here we go. So these are rotations, stack rotation amount. That works pretty well. Let me go and put that there. So now, the last little bug fix that we need to do. These are currently rotating 90 degrees off where they should be. So they're kind of parallel to the face orientation instead of perpendicular. I think that was the right phrasing. Okay, now to fix that, we simply need to cross product, because that will give us basically a 90-degree rotation. And now we should see, we may need to flip that around so that it is the opposite. There we go. That is now working. So there we go. That's the rotation axis. I should label that. Rotation axis. Sorry. Rotation axis. There we go. So now with that, we can see that's working quite well. There we go. And now the curve rolling is working quite nicely. You may want to set a, let's see, what should this be? A power node? You can use a power node to change the kind of interpolation for this to make it a little more powerful or not, or multiply clamped just to make the offset a bit more potent. Anything you want. Like this last rotation, you may want to keep unclamped just in case you want it to go above 1 or below 0. Just lots of customizability available there. There we go. So that is that. This is, I'll label this rotate vectors. Rotate vectors. And there we have it. Very nice. So this root position node is included in Blender by default, but if you want to add it in normally, like just get the start position normally, we can just copy. Let's see, which one is it? This one. And then it should work. Let me try this out real quick. I may be able to replace this with just the index. Just so that we're not relying... Oh my goodness. So as you can see, that doesn't quite work well. Let's see. What if this is on spline? Still doesn't work correctly, but very interesting. So I think we need to set that to point and set this to spline. Evaluate the integer in spline domain. Or I may need to... Yeah, let's just use what's pre-built in. Like you could just copy these nodes and then it would work, but sometimes just having them pre-built into Blender, it's not half bad. There we go. So you could do that or just have it not exposed. Okay. That's a little bit much, in my opinion. Oh, and that works even without that in there. Good to know. So should I keep that separated? No, it's good to have the knowledge out there, but let's just use the root position right there. And actually, I'll replace this with the main line 1. There we go. Okay, so there we have it. Curve rolling in less than 20 minutes. Not bad. If I edit this down, I may be able to make it into a proper YouTube tutorial. A little scatterbrained, but maybe effective. That should be good. Let me go and label this as mesh normal, or no, store normal. And there we have it. Not too bad. So that is how you roll curves inside of geometry nodes. Eventually, I want to make it so that this will work on meshes, but that is beyond me at the moment. So another thing, if you want to make it so that this works on meshes, that is a whole nother ball game. Another very difficult thing to do, so I will leave that for later. But that did not take too long. That took a shorter amount of time than the tessellation, but that's because I knew how to do this beforehand. So there's the knowledge out there for you to go and copy. You could also, again, smoothen these out as much as you want, and this will work. I should mention this. It doesn't need to only be geometry like humanoid shaped. This could work on text or string to curves. Let me go and try plugging that in. Let's hope this works. Wow. Okay. Or, wow, there we go. So we can see, let's realize instances. Ah, we can see that there's just a wee bit of trouble happening. Let's also trim the curve. There we go, just so that it's not cyclic, or actually, there's set spline cyclic. There we go. Does that work? No, that just, okay, so trim curve makes it so that it'll keep all the points, but it'll still be split. So there we go, and we also need to resample the curves by a good amount. Let's just put in enough geometry so that it'll work well. And now when we do this, we should see... Oh, right, we need to use the regular curve normal, it's because there is none stored. So now we should see, there we go. Quite nice if I do say so myself, even though it's a little comical. So we could just plug that into there. So they will stack up accurately, which may give unintended side effects, as we can see here. Yeah, unintended side effects. But if it works, it works. Actually, let's set that to like 0.2, but then just multiply this part by quite a bit. Ah. Should be working perfectly. Maybe, oh, okay. No, it is working perfectly. It's just that the rotation kind of radius was a bit much. And the one downside of this is that it doesn't rotate to align with the next part in the thing, which I did make a version of this that does do that, but that doesn't use the accumulate field node, oddly enough. Okay, so this is a pretty... It works, and I'm happy with it. So what else should I do today? It's less than 25 minutes. I am amazed that it took that little amount of time. But there we go. I'm actually thinking about making this into a full-fledged tutorial. So maybe I can try remaking the effect in a clean way, chop that out of the live stream, and then package it up, put it on YouTube. Put it on, you know, the main channel. Would you all be up for that? That may be a really good idea. Ooh, and I need to invert that. Or is that doubly inverted? I thought it was supposed to be the other way. Huh. Oh, no matter. Okay, so this is even more optimized than, well, that version, so I can just full on delete that. So let me go and delete this. So I'm thinking about how to do this properly. So I think I'll take out the smooth node, just because for demonstration's sake, we do not need that. Okay. So I'm thinking about how to set this up properly. And this is the end of the live stream. I will probably trim the live stream down afterwards because, you know, it doesn't need to be that long. So thank you all for watching, those of you who are watching the live stream in the future, and I'll see you in the next one. All right, let me think about this. So now that we're in post live stream time, we're in tutorial making time live, which is actually pretty interesting. Can I record and stream at the same time? That would be cool. You guys will have a peek into the YouTube creation experience. Okay. So maybe I should have an animated version of this. So I could, yeah, leave that. No, let's leave that clamped. Both of those clamped at the time being. Okay. So I will apply the triangulation on both of these. Or no, I'll keep that one untriangulated for the time being. And then I will keep this in the scene. And I will make the label bigger. But I will duplicate this and then reset the file. So we start out with only... Or no, I should start from scratch if I'm being honest. Yeah, let's start from scratch. Make it a more in-depth tutorial. Okay. So I'll say, hey, here's this fine mesh I'm working on, and let's go along. Use the edge length as the cost function. I don't think that's necessary in this case because the spline length will do the exact same thing. Okay. So let me get this started out. I will use the origins, but I will not... Should I have the mesh floor? That usually just... No, that's good enough. Because the grid here... Usually... Does that mess with compression? I'm not sure. We'll keep it just because it makes the scene look more official. Okay. So I will animate this. If I can remember where the animation thing is. Okay. Man, this will be weird actually making a tutorial live. Not bad. So should I have it so that it's rolling or unrolling? I think rolling is a lot less, unrolling is a lot less gross. Hello everyone, and welcome to today's tutorial where I will show you how to make this curve rolling effect inside of geometry nodes. So buckle up, this will be quite the tutorial, so get ready. Hello everyone, and welcome to today's tutorial where I will show you how to make this curve unrolling effect using geometry nodes. So, without further ado, let's get started. First of all, let's start off with a new base mesh. This one is triangulated, as you can see, because that gives us better shortest path results. So, let's get those shortest path curves. So to do that, we need to use the shortest edge paths node. There we go, right there. And I forgot, I need to enable screencast keys. So I'll be doing this a lot, so you'll be seeing, I hope you all find this fun, seeing me record a live stream live. Let's enable that, so that they can see everything that I'm doing. I hope that's not too big. Let me also go and move this down by a bit. And there we go. There we go. So... I'll make a full-on new geometry node scene. There we go. And maybe I'll do a little bit of editing after the fact. Who knows? Using the edge length as the cost will make it so that the shortest path is actually shortest. Not each length will be treated as a similar length. Not entirely. Because if I were to use the spline parameter factor, like this, it will treat it as if they're all the same length. That's how you get, you know, biblically accurate angel look and stuff. But with the length, it is the cost. Because, well, okay. No, I do see your point. Okay. Or would the factor be the same? I don't know, I do now understand what you were meaning. So let me try that really quick. So, this probably won't be the most practical thing because you need to assign an edge cost at the beginning. It needs to be non-zero. So I'll make it so that it's 0.1 for every vertice step. So now if I were to do that, we would see. So this, every vertice it hits will be doing something a little bit different. Okay, no, let's set that to 1. Interesting. Very, very interesting. Okay. I am actually very, very amazed. That's freaking out like that. So let me set that to 0.1 because that's more aligned with the curve's actual length. We set that to 2. Yeah, what is going on? So it kind of works, just it's a little odd. Total cost. If I remember correctly, this will be 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, and so on. I won't spend too much time on this, but it is working. It's just working very quickly. Huh. Oh no, that's the total. Oh, wait a second. I misunderstood this. So... Wait... I'll figure that out later. Let's not lose the momentum. Should I have it roll and unroll or not? The distance between the verts. The distance between the verts. Oh, wait, sorry, I think I misunderstood. Again. Oh, I apologize. You meant plug in the... Oh, wait, but there are no edge lengths. Or the vertex edge lengths. So, okay. Let me think about this again. So, I remember seeing that in the manual. So if I get the edge vertices node, and then get the distance between these two, again, this probably won't be in the impromptu tutorial, but there we go, okay. That's what you meant. Okay, thank you. So that'll give you the true total cost. So the true shortest path. Thank you very much. I now understand. Sorry for misunderstanding that. So that will give us the... Okay. So that. Not bad. Not bad. So to look at the difference... Very interesting how that gives us a much more natural pattern. But that is to be expected. Good to know. Yeah, I remember seeing that in the manual, but I just went in through my eyes and then just I did a RAM wipe. Okay, so let's get into tutorial mode again now that we have newfound knowledge. We'll see if I use that in the end. Let's set this to linear. Hello everyone and welcome to yada yada. This kind of curve unrolling effect inside of geometry. Okay. There we go. I think I'm all primed up. So let's go and get this moving. Let's try recording and streaming at the same time. Nothing could go wrong here. Okay. Hello everyone and welcome to today's tutorial where I'll be showing you how to make this curve rolling effect inside of geometry nodes. So, without further ado, let's get started. Let's go and start out with a fresh scene right here with a new character. This character is triangulated because that gives us better curve routes. So let's go and set up the curves. So for that we need to use the shortest edge path node to get the shortest path from a certain point. In this scenario, I'm going to assign a vertex on the back right here to this vertex group. And then we will reference this in the geometry node editor using a group node, a named attribute node. I think I'm going to restart that because I messed it up. I forgot the script. We can't be having that. I do that quite often, so I apologize. Again, I am recording a tutorial live while I am streaming because we already finished what's going on. If you want to see how to make this properly, just record the live, go back in the live stream and you should be fine. Okay, let's get this started again in 3, 2. Hello everyone and welcome to today's tutorial where I will be making this curve rolling effect using geometry nodes. So, without further ado, let's get started. Let's start this out on a nice clean slate. There we go, forgot the script once again. Now you see why I have stopped doing tutorials. You forget your script quite often. That's why I like doing the live streams. I could just flow and not worry about messing up and having to restart. But let's do it again. Like sometimes I could get these tutorials down in one take, which is very nice. But the problem is it's usually one take or 20 takes. But I have time today, so that's good. We're only at 38 minutes, so I could be doing this for quite a while. But hopefully this is entertaining and not boring. So let me go once again. Okay, 3, 2, 1. Hello everyone, and welcome to today's tutorial where I'll be showing how to make this curve rolling effect using geometry nodes. So, without further ado, let's get started. Let's start on a clean slate. This will be our base mesh. It is triangulated to get better edge paths. So, let's set up our curves based on the edge paths. So for that, oddly enough, we use the edge path node, the shortest edge paths node, and then we convert those edge paths into curves using the edge path to curves node, just like this. So we connect this into here and this into our geometry. But we need a start location. In this case, I will assign this vertex with a vertex group, and then we will access that vertex group using a named attribute node. So let's go and select our group and plug this into the end vertex. As we can see, we get all the edge paths, just like that, which is pretty nice. Let's go and put this over to here. Now, one of the issues is that we have too many end points, or start points in this case. So to reduce those, let's go and just have a random value node set to Boolean and reduce the amount until it looks good. That seems good enough for me. Let's go and put this into a frame and move it over to the side. That's pretty good, and I will label this curves. There we go. Now, if we use a trim curve node just to see how it works, we'll see a little issue. That's because they all start out at these, what looks to us as the endpoints, as we can see here. So we need to reverse this curve so that when we do roll them, they roll from the back point to all the other points. So for that, we just use a simple reverse curve node, which is pretty good. So now is where things get complicated. So buckle up. We will use a set position node, and that's the last geometry node that we will need. We're going to be taking the position or the curve vectors, but that will come later, rotating them and then plugging them into that position output. So first of all, we need to go and get the vectors for all the points on this curve. And to do that, we need to compare, or subtract in this case, the position of one vertice and then the position of the next one in line. So let's set that up very quickly. So position, and then we need to subtract from the position of the next point in the curve. So that is a little bit complicated, but we can do that. So if we use the offset point in curve node, just like this, we can get that. But we need to do a few things. So let's use an evaluate at index node so that we can get that position, but it's referencing the index of the next point in the line. So if we do that, that should work okay. But a little bug fix that we need to do is say if it's at the end of the line, then switch back to just the normal index so that it doesn't freak out at the beginnings or the ends. So for that, we use the isValidOffset, and we put this into the switch node. We need to set this to an integer. Let's put this up here. So if there is a valid offset, we set that to true, and if not, we just revert back to the regular index, just like this. So now this part should be working. So that gives us the next point position. Apologies for my misspelling. There we go. And then this will give us the curve vector. So now that we have all these curve vectors, we now need to reassemble them. And I should probably label this as well. Curve vectors. There we go. So now to reassemble these curve vectors, we need to use an accumulate field node. This basically stacks up the vectors, or whatever you put into here, according to the group index. So at the beginning, it'll be like 0, 1, 2, 3, 4, 5 as you go along the line. So we can plug this in here, but we need to set the group ID for every single spline. So to do that, it's fairly simple. We just use the index node and then evaluate this on a domain. In this case, we want the spline domain. So if we do that, that should work. So now, if we go and plug in the leading into the position output, we can see that it is currently broken. Let's go and see why that is happening. Let's see. Right, we need to actually offset the offset by -1 in this case. I think that works quite well. So there we go. Let's put that there. That is working. So this part is working. Let me label this as assemble curve vectors. Curve vectors. And there we have it. Let's move it over to the side. And now that we have all these vectors, we can rotate them. So to do that, well, actually, one thing we need to do first. All these locations are starting out from 0, 0. So we just need to add the curve start position. Fortunately, there is the curve root node, which is in the here thing. So curve read curve root. This comes pre-installed into Blender, but it is a node group, which can lead to very interesting finds if you go and look through there. So let's go and add that into there. And now if we hook this up, we should see that it now works almost perfectly. Let's put this into a frame, and let's label this add start position. There we go. So that's doing pretty well. So now let's rotate these vectors. So if we just use a rotate vector node, or vector rotate node as it is called, we can see that they're rotating, but they're not rotating correctly. It's usually implied that when you rotate one, the points next in line will inherit that rotation. But unfortunately, we need to implement that. So fortunately for us, we can use the same node setup that we have here, switch it to float, and label this assemble curve rotations. Let me make that plural. So now if we plug the leading into here, we will see now that the rotations are stacking. But we can see just another little problem appearing. And that's that all of these are rotating on the z-axis. Well, we need to make it so that they're rotating on the normal of the object. So to do that, we simply need to store the normal. In this case, I will store it before the curves. That's very important. Let's set this to vector. Let's have this be the normal. And let's label this normal, just so that we can reference it later. Let's go and also put that into a frame. And now that we have this, we can go and plug this into the normal and plug that into the axis. Now we can see that this is working. It's a little chaotic, but let's make it a little less chaotic in just a second. So to do that, let's go and get the spline parameter right here. And here I'm going to use an add node, and I will clamp it, and then plug this into the assemble curve vectors. So now we can see that we already have it kind of working. But we can see there's just a little problem right now. And that's that these are rotating in the wrong axis. So they're rotating sideways instead of vertically relative to the normal. Fortunately for us, there is a very easy bug fix for that, just one node. So let's use a vector math node. And we set this to cross product. This will effectively rotate the normal by 90 degrees. So there we go. We can see that is now working. Very nice. So let me go and put this into a frame and label it rotation axis. Very nice. Go and put that there. So now we can go and play around with this and customize it. So here we can see that these are just rotating, which is fine. But what if we want to make the rotation amount bigger or larger, the kind of radius? In this case, we can use a multiply node to go and make it larger or smaller, just like that. Tying up the curve amounts, and this controls the... Well, it looks like we have a little issue. Ah, that's why. You need to make sure that this is positive, or else it will start caving in on itself, which maybe you want. Okay. Now, if we were to go and use the curve factor, we can see that we get another very interesting effect right here, which maybe you want. That's another customizable trait. But in this case, I will keep this as the length. And another thing that I should mention, if you use a clamp and then multiply this, you can also change the effective kind of interpolation between no rotation and then the rotation amount you set right here. That is optional. In this case, I don't think it's needed, but it's good for me to show that. So let me go and put this into another frame right here. This is just rotation amount, just like that. And there you go. You now have the curve rolling effect inside a Blender, and you can apply this on any object. So I can go and demonstrate this with an icosphere. Let's make an icosphere with a fair amount of polygons. Let's go and assign a rotation point. There we go. Now we can see, as we scroll along, this is working. It's actually a little too low subdivisions, so let me subdivide it again. So lots of cool things can be made with this effect. Let me go and delete that. What else should I show off? To animate this, you simply go and put in a keyframe at the animation end, and then the animation, beginning then end. There we go. Put another keyframe, and now we should see that it is now rotating into place. So that is the tutorial. Thank you all for watching. Be sure to check out my Gumroad page and my Blender Market page. I have many fun demos and products up there for you to see, download, or purchase. Thank you all for watching, subscribe if you liked it, and I will see you next time. Oh, and let me show off the entire node tree so that you can see it. Thank you all for watching, and I will see you next time. Show recordings. Hello, am I still live? I apologize if I ended the stream. I did not mean to do that. I meant to stop the tutorial recording. But there we go. Here, let me just make sure by changing the scene. Oh no, yep, I'm still live. But hello everyone. How's it going? I hope you had a good day. I hope that seeing me record a tutorial live was entertaining. Yes. It's a kind of an impromptu one, but I hope that it can, I hope it can help some people in their geometry nodes journey. I think there's a lot of knowledge packed into that. I'm still not sure if I'm streaming or not. Yeah. If someone could just type in, like, hi or something in the chat, I would appreciate it. Just to make sure. Okay. So now I guess I could experiment a little bit more with this. Thank you very much to everyone who said hi in the chat. Thank you very much. I accidentally stopped streaming with OBS, so I was like, oh no, what did I do? Because I meant to click the stop recording thing for the tutorial. I wasn't sure if it was going to restart. But there we go. There is the setup. I'm quite happy with that. And I even got the Gumroad plug-in at the end. Very happy about that. Okay, well, not one take. That was like the third take, I believe. But yeah. So what should I do to experiment on this? I want to try out new effects with it. Or, here, maybe I'll go and bring up the... Well, one, I should save this... I should put this up as a demo up on my Gumroad, or maybe paid, because I do have a tutorial up for it. Just maybe. Not sure. This is a very interesting effect. A couple things I want to do. Which one is more compact? That one's better labeled, so I will keep that one. I do want to implement the randomized triangulation. So, triangulate, there we go. That's a very simple node setup. It's just, oh, randomly do this or that. I do also want to try, as Eric suggested, putting in the edge cost again. So let's use edge, edge neighbors? Nope, that's not the right one. Edge vertices, there we go. Get the distance, just to see how that affects the... that right here. Very interesting. That's very, very good to know. How does it affect a square mesh? Very interesting. Wow. Another way to make a blooming flower? Yes, yes it is. The big step I want to take next with this project is to try to make it so that you don't have to use the sun curves. That will increase the complexity by an extreme amount. I saw, today I was researching how to do this properly with actual math. I didn't find too much, but I did find an Intagma tutorial, which basically did this. Are these caving into the inside? No, not. Which basically did this effect, but on a mesh. But the problem is, they used loops, which we do not have in Blender. In here, the accumulate field node is essentially doing a loop, which says, hey, do an see what the field is or the value is on this vertice, then the next vertice, stack them up. Then do the same thing over here, stack them up, stack them up, stack them up, and keep doing that for all the vertices. It's surprisingly fast, given that. So I wish we had that power inside of geometry nodes, but alas, we do not. Such a shame, really. But hopefully that will be coming in the future. So I trust that the Blender developers will create an elegant solution for that. There are mock-ups, but they're still deciding on that. They want to get geometry nodes, the simulation nodes down before they elaborate on the other stuff. Not bad. Not bad. Maybe I should package my tessellation tutorial, my tessellation livestream into a tutorial. That may do well. And what's a good clickbait title for the unrolling thing? How to unroll nerves in Blender. That would be a very funny one. Just have like, no, not that thumbnail. That's not quite good enough. That makes a statement right there. Something doesn't feel right about... I think this is because... Ah, that's why. That could be a reason why. So just like this, that's a good... Not quite clickbait, because I did show that in there. It'll be like, wow! You'll never guess that node made this awesome effect happen. That's too clickbait for me, I'll be honest. So let me... Did I record that entire thing outside of full screen? No, there's no way. Let me check that real quick. Okay, no, that was... Whew. I am so happy that was full screen. I was very fearful of that. But there we go. So I'm thinking something like that. Except, you know, it's almost entirely full screened. And then I just have text, text, text. Roll curves, make horror. or something like that. There we go. So I could just, like, take a screenshot right now. It's kind of an example. Or maybe one like this and then one without the changes on it. Let me duplicate that, so... Dang it. So one normal, one extreme pose. So one like that, one like... Ooh, yeah, actually. The different colors enhance it. So, I need to see... Are the colors strong enough to pop out? Maybe I'll change the focal length. I'm thinking about this just a tad too much for just a YouTube thumbnail. But maybe it will help some people. So I'll take one screenshot. Let's make this full screen mode. Whoops. New. Oh wow, that made a sound. That was way too loud on my end. And it took a screenshot of all of my monitors. That's very nice. You can't see this, but let's do new. If that makes a sound every single time, I'm going to freak out. Okay, good. Because that was way too loud and very weird. Let me go and save that as just a serial number. Now let's make another one, just with both of them in frame. Okay. Oh wait, I need to make that... Yeah, let's keep all the UI elements. I can change that later. There we go, let's save that as another serial number, because I never name things correctly. Okay. So what else can I try to do with this effect? So we have that, and we also have the index. But that... Wait a second, does that give us the spline index? Have I been doing this wrong this whole time? No. Okay. Okay, no, never mind. That just gives us like the 1, 2, 3, 4, 5, 6 along the spline. Windows plus S for screenshot. Let me do that right now. I keep forgetting that. Windows S. Nope, that... Okay, need to do. I keep opening up the menu. No, that doesn't seem to actually be working. Huh. Is it Windows plus S? Or Windows Alt S? I find it funny that you can see it happening there. Maybe it's because it's treating it like a game, so if I were to, say, click out, then do that, did that work? Interesting. I'll have to figure that out later. I just used the Windows snipping tool. But yeah, that's how you do that effect. Okay. Anything else? It is interesting how there are some differences there, but when I do that, it just clicks. Then I could take the total edge cost and then plug it into here. It still gives a very different result. Oh, I saw this on Reddit. Yeah, I don't post often on there anymore, but I did today. And it actually, you know, it did pretty well. So I'm happy about that. Okay. So in terms of experimentation, how would this work? Like, I could try... I'm actually not too sure about this. How would I make this work but on the mesh itself? So no curves involved. Just using the next vertex index node. Would the accumulate field node? No, it wouldn't. Total cost. I left when you said that's it before. Oh, sorry about that. Yeah, I was recording a tutorial inside of the live stream, a little bit of content inception there. So I recorded that because this project, me setting it up, I was able to do in 20 minutes. And I was like, wait a second. I could just do a tutorial right now before I can be lazy enough to not do it. And then that would be good. So I did a, like, 11-minute tutorial on how to make this effect in its entirety, which I am amazed by. I didn't think that that would be possible. But I did it. It works and all that. But at the end, I was just like, hey, check out the Gumroad and all that. So I apologize for that. I should have put up a little disclaimer on, well, I can't really do that for the stream versus the recording. I should have said, hey, I'm doing a live stream now. Or like a YouTube recording. But yeah. All in all, we're past an hour, so I should stop streaming now or soon. I just want to try a few last things. But this will be trimmed down to about like 25 minutes or so, or maybe I'll keep it up in its entirety. Just for kicks. But setting this effect up with just the little bit of bug fixing took 25 minutes, and then I was like, okay, if I optimize this and don't make any mistakes, it'll take like 15 minutes. All in all, it took 10 minutes, which I'm not upset about. Okay. So other things I do want to try. So what if I used noise with the length and then put this in here? Let's go and scale this down. Intriguing. I am surprised. Let's subtract by 0.5. I'm surprised that it's not. Sorry if I say that a lot. I'm very surprised that that didn't work out. Oh, okay, there we go. So there's the noise working as intended. But the problem is. Yeah. So it's kind of working. So, another thing I have been wanting to do is make like a lightning effect using, you know, the stacked stuff. That actually is a very cool silhouette for a horror monster. Like here, I kind of see like a dragon head. And then there's the dragon if you... Here, actually, I have my drawing tablet out so I can go and show my design. What I am seeing in my brain in real time. So let me go and annotate real quick. So I see this as the dragon head right there. Let's just put a nice eye in there and stuff like that. That's like the plume of its tail or something like that. So all it needs is like wings like that. And then boom, you got a really cool dragon or a griffin maybe. I was doing some drawing today, so I'm just like, oh, let's do a little bit more of that. Today seems to be the day of, oh, let's keep the momentum going. So if I were to hide that, now we can see, ooh, a cool, very quickly sketched out dragon. Or griffin in this case. Or no, phoenix, not a griffin. Phoenix. That's a very terrible beak. Here we go. But yeah. I don't know, I just have a lot of energy today, so I apologize if I'm a little more hyper than usual. I woke up early, so that's... maybe I should start waking up early, and then I would stop being tired. Who knew? Where are they? Yeah. How do I delete the current annotations I'm working on? Ah, there we go. Let's unhide this. So I do want to try this on other objects. Even though I do need to keep this current version, I keep thinking I'll go and just wipe the scene, but again, I should put this up on Gumroad. This will be curve roll. So I should split this into several things. So triangulate, curve setup, and then curve roll. Or maybe I should keep it all in one go and then put it up as a demo file. I'll think about it, but I'll probably set that up for later. We'll see about that. Because if I did make this into a node group, well, one, I would want to break this out of there, which isn't bad. We'll see. I also want to show off, so let me save this as roll curves tutorial. There we go. So I'm going to go and open one of the other scenes. Oh, I wanted to showcase this one. May take just a second for it to load up. So this was the main starting point for this project. I spent quite a long time, more time than I would like to admit, working on making this effect, which was pretty cool. I liked it. Where basically I take the shortest edge curves, trim them, or kind of trim them, but sample the positions and then reproject that onto the mesh. That was very painful, especially the rotation here. Because rotations, undoing Euler rotations, you need to do this, and that's very, very annoying. But all in all, to get the face rotation, it did work out eventually. Just using, or having the position offset wasn't too bad. Just doing that. But in the end, having the rotation was nice. I should also show off what this looks like with the monkey. Classic monkey. Let me go and put this up here. And also I need to set the start position. There we go. So that looks very cool. Like, if I have an idea of, like, I don't know, I was thinking like a sci-fi ship forming out of this effect, which would be very cool to see. I also want to try this on a Taurus knot to see how it would affect everything. Oh, there we go. Oh, that's extremely interesting. You can see why I would be so excited to try this out on other sci-fi creations. Because here, since it's all mathematically set up. Sorry if I'm going too fast for my words to form. And here we can see that the math still needs some fixing. Like here, this could be optimized. Which actually, I will try to do that live. Actually, no, because I'm going to reset the file. Where's the progression? Here it is. So here we can see when that happens, they optimize first, because again, shortest edge paths, and then go like that, which is, again, very cool. It's also interesting that some of them decide to go the opposite way. Actually, no, that is to be expected. If I took out the length, what does it look like? Okay, that's a lot simpler. So they just form and then do that. So even if I just use the spline parameter as I am, the shortest edge paths do sort of apply. Which that is a really cool kind of algorithmic feel to it. Let's try another shape. What are some cool shapes that the extra objects thing give us? Diamonds extra. Beam builder, a wall factory, a simple star, the Mesner sponge. Let's make this a 2-level one. None of that. Yikes. Yep. Normals don't really work on the Mesner sponge. Because actually, no, they should be working. Does that have custom normal data? Interesting. Oh no, I know why that's freaking out. That's because I stored the normal in there, which actually was a really bad idea, which I fixed in one of the later versions. Yeah, let's set this up. So this will be a really cool volumetric version of the effect. Let's go and just move the progression manually. So here, this is kind of what I envisioned. Just something like this, extremely algorithmic. And then it just forms. Which actually, that's very cool how it does that part. So that just does that, and then do. I should also implement the edge vertice thing that Eric showed me. Thank you very much once again. Let's get the distance from there to there. Have you tried using Houdini? Once for a job. I found the naming a bit confusing. Like, okay, I wasn't too invested in trying to learn it. So I was just like, I tried it out and I was like, no, let me go back to Blender. And I liked it. Even with, I tried out Houdini even a few years ago, and even then I was like, no, let me use what I'm comfortable with. Especially with Houdini being paid. If you learn Houdini, that's very good. Houdini is the best in the business. The thing is, going from Blender, I didn't have the mental power to try to transfer to that and learn it. So I would definitely recommend it. It's much more powerful than Blender, much more widely used than geometry nodes. And, you know, comparing geometry nodes to Houdini, geometry nodes has like 1% of the power that Houdini has, just because Houdini has all the built-in nodes. Here you have to do everything manually. But the thing is, you know, some effects, you know, it's the same workflow for both Houdini and this. Like making this effect in Houdini, it may be just as hard to do it in Houdini, because I've never seen it really done before, but I could be wrong. But it may also be a lot easier because you'll have loops. That's the big separator between Houdini and Blender. They have for each loops. They have coding interaction. We don't have both of those, and they have a lot of built-in stuff, like the solvers and all that. We don't have that, so it's unfortunate. But yeah, maybe one day we'll get a fraction of that power. Well, we will be getting a fraction of that power once we get the loops. And I hope we get just a little bit of a coding node in there, but we will see. Any recommendations for Blender in the meantime? I have beginner geometry nodes tutorials, proper tutorials on my page. Arendelle has many good geometry nodes tutorials and some very advanced stuff. Geometry nodes gets advanced fast because you basically need to learn trigonometry and maybe even calculus along the way, physics and all of that. I have no formal training in any of that, or, you know, like college level training. So I'm learning it on the fly. All of my frustration it's because I don't know how to do this. I don't come from a programmer background either. So I'm learning this as I go. And it's turning out okay. But just to prepare you, it's a lot of math. Have you rotated Eulers? Do you know how to undo the rotation of Eulers? If not, you better learn. It can be annoying. But yeah, just to say, I would recommend learning Houdini, but no matter which path you take, it's a lot of math. DFL Cube is good at explaining the math. Yeah, I don't think I've ever... I need to go and look up their geometry nodes tutorials. Because I used to watch them back when, well, before geometry nodes came out. I haven't really seen... I've learned geometry nodes more on my own, so I haven't really looked at the other creators in that space. Intagma is one of the best Houdini and geometry nodes tutorial makers out there. They made a Plexus effect in geometry nodes. I did not think that was even possible because of the lack of loops, but they found a workaround in order to make it, which it's a little bit laggy, but it does work. I can actually showcase that really quickly. I do want to revisit that and then like make a spaceship appear. Maybe I should try that on like a model I import from Sketchfab. I should try that, and I probably will off stream. But let me go and open. I need to find... Where's Plexus? Where's Plexus? Plexus connections. That's in 2022 projects. Now, where's 2022 projects? 2022. There we go. Plexus. I updated it recently, but it's still in that folder. So... I optimized it a bit. I changed up the tutorial just a little bit. So here's the kind of optimized version. So we start off with just these points. The points go and move around. But the thing is, you need to make lines going from every point to every point, which gets laggy very fast because you're going to the points to the power of 2. So to do that, I take the point count, duplicate them by the amount of points in the scene, essentially setting them to the power of 2, as you can see. Detecting which ones are duplicates, deleting those. But I also store the position of the other points, dependent on the duplicate index, which that's the part where I just had to rely on Intagma because I did not really understand why that worked. I just changed it up so that you use the duplicate index instead of creating new points and then doing a lot of like wrap in fraction modulo math. So that's what I did. And then you go and delete the extra points. Then you delete the points that are too far away, shown there. And then you go and instance some curves. And then you set the endpoint to where the endpoint should be. And there you go, Plexus. Which, all in all, is not ridiculously difficult. It'll take you 30 minutes to set it up, but it's not the most difficult thing on the planet. And then, then after I did that, I set up the thing like this. And actually, I should make... I'm thinking of proper tutorial content right now. But I'm thinking of a series of explaining node trees. So here, since Intagma made the tutorial, I don't want to just remake the tutorial, but maybe I would make a video saying, hey, here's how I optimized Intagma's Plexus tutorial. And then I would say, here I have the start points. Maybe I'll record another one right now, just to keep the momentum going. So here we have the points going, and then we duplicate the amounts. So if I use a set position node and offset them by the index, that would be like a thing. I have as many I copy the points by the amount of points that are in the scene, so we can see all the amounts right there. Kind of like parallel universes, almost. And then with that duplicate index, we go and get the positions from the previous points. So for every point, they see the points of every other point. So we store those, and then we also store if they're duplicates. And then we go and delete. Like, I could take out the stored is duplicate thing, which actually is better. A little more optimized. But the thing is, I need to make sure I don't do that beforehand, because that might mess with the indices. Let me see, does that mess with it? Yes, it does. So I need to do that after. Oh, wait. This may optimize things just because it's not it's not storing another attribute, which may be really good in this situation. I should do a speed comparison. Okay, so let me try that out. So let's see the speed without all that happening. Let's look at the timings. And again, I'll need to end the stream soon. So this takes around half a millisecond. How does it work if I don't store that? It is less by just a little bit. So let's do it. If we can optimize a little bit and use less nodes, the better. And it is kind of optional if you don't delete the duplicates. Again, that's something that Intagma said, but I do not fully understand it, so I will just trust them on that one. And here it's the delete if too far. Let me put this into a frame. And also let's disable the timings. Just optimizing everything. Then we instance the curve, and then we set the end position. This is prime material for a tutorial like that. Or if I want to make it, you could just could extrude mesh, make this vertices, plug that into there. Oh wait, but then I need to do, nope, this is a better version. Oddly enough, I don't like converting points to vertices just because it feels so redundant. I'll go and put that there just, yeah, for that. So here we have some start points that are just floating around in the abyss. I'm kind of preparing for the tutorial. And the thing is, this can get extremely complex. Or extremely slow very, very fast. Because if I take out the is too far thing, the amount of edges goes up exponentially. Exponentially? I think so. To the power of 2. That's no. That may not be exponential. No, the power of 2. That's not. Okay. Where is it? Sorry, my math brain is not working at the moment. So there we go. So right now, the amount of control points is 1,500, while the input is 50. Or no, 2,500. So if we do 100, 100 times 100 is 10,000 in this case. Yeah, that checks out. So if we were to do 1,000 by 1,000, all of a sudden we get 1,000,000. So yes, that is sorry, I need to look up what exponential is again. I keep forgetting. So 10 is 92. Oh, that's because it's deleting the duplicates, if I'm correct. Yeah, okay. So 92, 100 is 10,000. 100,000 equals 1,000,000. Which, as you can imagine, is actually faster than I expected. So if we delete the far points, that just takes it down because this is, variable. So here, you have just the correct amount of Plexus going on. I am still amazed that this is as performant as it is, while this is operating on 500,000 points. And then you just reduce that, and then, oh boy, yeah, we can see it starts to lag there. Or this could be done with like the shortest path, find index of nearest node. If we can find the second nearest and then the third nearest, then the fourth nearest. Because this sees all the nearest, no matter how far away. We can keep doing the connective stuff. Put that back to 1.5, and then reduce this back to 50. Actually, I think it looks better with more points, but reduce the amount so that, there we go, Plexus. That demonstrates it better. And then we have the meshing, but I don't think that's necessary, at least with all that. Let me just go and set up the most basic, you know, just so that it is visible. And position, delete if too far. Delete if too far. There we go. Let's go and join areas. I recently learned to do that in vanilla JavaScript. Interesting. It would be interesting to see the math on that, the code. Okay, I would like to see the code on that because, you know, geometry nodes is so visual. But seeing that... Actually, let's see. That is duplicate. What if I set that to a less than node? Like, at that point, you know, it's just like, oh, let's make it so that the lines look right. But I'm not going to tempt fate with that. Duplicate elements and all of that. I'll compile and send it later today. Oh, thank you. Yeah, I just like seeing the code behind it. But thank you very much. Thank you very much. So there's that. Instance curve. Set end position. Yeah, I should end the stream soon because we can see my brain starting to slow down. Plexus. Plexus. Based on Intagma's tutorial. Plexus. Based on Intagma's tutorial. There we go. Group properties. Let's go and make it bigger. Maybe 40 seems good. And I could put that just on a reroute. Like, one thing I like doing is making headers like this. Plexus, based on Intagma's tutorial. It's 2D though, the logic is the same. Draws lines and the lines are at a certain point. At certain points. Okay, yeah. Plexus in 2D and 3D seem... Yeah, it would be the same. Like, that's actually very interesting. Usually 2D to 3D conversions of effects are very difficult to do. Or, you know, just more complicated, because usually the third dimension interacts with everything and messes everything up. But in here, you're literally just saying, hey, create a point that goes to other points. So it's just like, the two kind of pieces of data that you need are how many other points are in the scene, and what are the positions of all those points, regardless if it's 1D, 2D, 3D, or 4D, or 5D. So in theory, you could make 4-dimensional Plexus, or 5-dimensional Plexus. Or as many dimensions as you want. Which actually, wait a second. Yeah, no. Yeah, that would work out perfectly. Or close enough to that. Why is that divide in there? I'm not sure. But again, not going to test fate. This is the node sep, so that if the x is greater than that just get rid of 1 point? I don't know, but it's interesting. Like, let me take out this and see. Oh, okay. I think I understand what goes on. What's going on. So that essentially doubles the amount of... Okay. So yeah, it would make, basically, it would copy this twice if that didn't happen. So maybe there is a way that I delete the duplicates and then... I need to try this out. Or... I need to see if it's possible to have the position stored second. It still function. Wait, is it functioning perfectly? Like here, those delete. But I'm worried. Okay, I need to make a kind of... I need to use a switch setup to see what changes the effect. So let me try that out. Let's just optimize the Plexus. I'm enjoying doing geometry node stuff. Which... turns out, taking a break and not streaming every single day was exactly what I needed. So wait, there is no difference? I need to try out a random radius. Set curve radius, just to see if the default index changes between the switch. It doesn't. Okay. Well, that's good. Yeah, the setup is... okay. Oh, another optimization right there. So I really should make just a little overview of the nodes. I don't want to replace Intagma's tutorial. I want to show an optimized version of it. Of my design. Maybe I'll call it the Express Plexus effect. Based on Intagma's tutorial. Yep, that makes sense. So the deletion happens first, which I was worried would mess up things. That just really reduces. Now that the store position happens after the deletion, or maybe I can make it so that those points don't even spawn in the first place. Maybe I could optimize this even more. So let me create an alternate version of this, where instead of this part happening, I envision where we don't even spawn those in the first place. So we would take this, divide it by 2, because I assume... divided by 2. And the question is, did that actually work? Because if it does, that will be a huge improvement for everything here. So let's try, first of all, a switch node. Then I need to try that radius thing again. Ah, no, it does not. Dang it. Let's see. What if I multiplied this by 2? Would that fix it? No, it does. Aww. A little bit of a shame, really. Or what if... Like, I assume the duplicates are just 2. Let's take a look at the spreadsheet once again. For past an hour and 30 minutes, I should very much end the stream. Then I need to trim down the stream to just the first 25 minutes, because that's how we were able to set up the effect so easily. Hmm. So without the deletion... wait a second. I need to view the amount of points here. So let's take a look here. So 20,000, that's 40,000. So there are just... greater than or equal? Interesting. So when I get rid of the duplicates, one... I'm going to assume that one is not needed. I really hope so. It would be a shame if one of the connections got botched by my stupidity. Because as we see... Actually, yeah, one of them is missing. So I may need to just add one. Ah, okay. So I literally just need to delete one, or subtract one, and then it works. That is annoying me greatly, because that means... Dang it. Or maybe, okay, let me try something else out. Because that's a greater than. If I make that a less than... Ah, there we go. That fixes it. Good. If I invert that... No, that gets rid of it. So I could keep that as a greater than, but just switch the inputs here. And that will keep... Wait a second. It's one more! No! Aw, so I need to add one either way? Dang it. Wait, what? Oh wait, is that just an integer conversion issue? To integer. Floor. Ceiling. So if I were to flip that around. Floor. Round. Okay, so round does work. Good to know. Let's set this to less than and flip these around just so that, you know, it looks right. Okay, so that's perfect. That's just to get around the implicit conversion. And maybe I'll put this here. So that the data, yeah, that's cleaner. So the question is, can I eliminate all those steps entirely? Again. So here we can see... Okay. Wait, so that did work? At least on a visual side it did. But I think we realized later on... Yeah, okay. The connections are not proper. So I need to negative or divide. No, that just ruins everything. Multiply. Oh no, wait, we do not want a multiply. We do want the divide, but then that mixes up all of the... That mixes up a good amount of stuff. So, let's just leave it as is. It would be nice if I didn't need to add in all... Maybe there is a way. There needs to be a way. So if we switch it to the alternate version. So a lot of those connections get broken because they decide to go to duplicates essentially. So I need to... Dang it. I thought... There was a thought in my head of, oh, maybe that'll work. Divide, multiply. I'm just trying out random things to see if something would work. Wrap? Ding ding, nope. Closer, but not quite. What if I just put in the index? Just the regular old index into here. Again, unfortunate. Oh, wow, that ruined it. So maybe there's a way to do that better, but I'll either need to test it or just go with, you know, what works. I've done more than enough optimizing on this to fix it. I should also make that, okay, maybe not that big, but, you know, just big enough. Start points is kind of a main thing. Start geometry gets fed into there. Position of others. Yep, that makes sense. Store position, delete if too far. Instance curve, set end position, then mesh curve. And join the areas. I'm happy with that. Maybe I'll put some reroutes. You know, just to really emphasize, hey, that's the start. Input geometry. Yeah, that's a bit more understandable. So input geometry. Yeah, that label is big enough. So input geometry points to the square of 2. Delete duplicates, store positions, delete too far, instance curve, set position, mesh curve. Not bad. I'm happy about that. And I can label this Plexus. Again, I would have to put in some redundancies to make this as generalized as possible. Because right now, if I were to, say, just have like a cube as the input, it wouldn't work. Because I would need to convert the mesh to points. So if I were to say to put in a mesh primitive, let's do an icosphere. Icospheres give very interesting result. Oh god. Are we good? Oh. Uh-oh, looks like my algorithm is broken. Good to know. Before I go and say, hey, look at this fancy optimized version I made, I need to actually make sure it works first. And wonder why it does not. What did I break? Whoa. I've used that on other meshes before. Why is that freaking out? I've used that on icospheres before. Mesh to points, duplicate points, yes, delete. Extras where we can see that one is being deleted, that shouldn't be. Oh, it's because they're too far. Maybe. So if I take out that... Okay. Oh, no, it does work. Okay, good. Whew, that's a relief. Now what I'm wondering is why, there we go. So if I... Okay. Okay, it is fine. Okay. Ooh, started panicking for a little bit. But that's how it would work with any mesh you put in. You just need to convert it to points. And then also make sure that the, delete if too far thing is, at a good distance. So yeah, let's try that with... Here we can see. There you have the icosphere, just plainly. And then there... Actually, wait. Can I get cool meshes with this if I make this an equal to node? So let's have this at 1. Again, just for testing. And made it so that it will delete unless it is equal to in a certain range. So here we can see there's the icosphere. Now if we go farther, we get this interesting mesh, which I cannot properly mesh, but again, interesting. And we get the intersecting points. Very cool. Let me try this with other primitives. Maybe a cube, and then maybe a subdivided cube. Let's set the amount of vertices to 5 and see what happens. So let's look through. So here. Uh-oh. Oh, good, that is still. I was worried that was uneven, which would lead to a bug in my code. So here we can see just the furthest points from each other, and the second furthest points from all the other points, and so on. So we get this very nice light show, and oh my gosh. So here's the closest points to each other. Closest. There's all the second closest points. So that's what you would do if you wanted, like, soft body dynamics. Get the positions of all the nearest points. There are all the second nearest point, or no, third nearest points. And then there's all the fourth. Then the fifth. Then the sixth. Very interesting. Very interesting patterns we're getting. Okay, we're coming up at 1 hour and 50 minutes, way longer than I first anticipated. Let me kind of try to reset that. So let's set this to greater than. Once more. That is quite the pattern right there. Alright. Thank you all for watching. This was a very productive day. I was able to get a full-on tutorial done and optimize my Plexus effect even further. Again, it's based on the antagonist tutorial, but optimized. Another good perk of this effect is because you duplicate the points, you keep most of the data from at least one of the points, so you only have to interpolate one of them. Well, if I'm correct in Antagmas, you had to interpolate both every single time. So just one more little perk with this optimized version. Alright. Let me... want to see the most dynamic looking version. There we go. Very nice. So thank you all for watching, and I will see you next time.